it is difficult to determine the velocity of light in each medium. Therefore, another method of determining refractive index of media was needed. Wilbrord Snellius, a Dutch mathematician, discovered the relationship between the angle of incidence and the angle of refraction for two given optical media. On the basis of this knowledge, he proposed a law to measure the refractive index of a material. This law is known as Snell's law. According to Snell's law, the ratio between the values of the sine of the angle of incidence and the sine of the angle of refraction for two given optical media is a constant quantity. Snell's law can be verified through an experiment using a glass slab, a white paper, and some pins. For this experiment, we put a glass slab ABCD on a white paper and fix this paper on a wooden board. Next, we mark the boundary of the glass slab with a sharp pencil and then remove the slab. Then we mark a point P on side AB and draw a normal NP-N1. In the next step, we fix two pins, P1 and P2, at an angle of 30 degrees to the normal in a vertical position. A minimum of 5 centimeters of distance is kept between the pins to ensure that the points are easily distinguished. Now the glass slab is placed back on the paper the way it was before. On looking through this glass slab from side CD, the pins P1 and P2 appear at positions L1 and L2 due to refraction. Next, we fix two other pins, P3 and P4, where they are in line with the images L1 and L2 of the pins P1 and P2. In the next step, we remove all the pins and draw small circles around them. We join P3 and P4 to meet CD at R. After joining PR, we measure the angle of incidence P1PN and the angle of refraction N1PR. Finally, by finding their sine values and applying it in the formula, we find mu is equal to sine I divided by sine R. If the experiment is repeated using different values of angles of incidence, the refractive index remains the same. Thus, this experiment verifies Snell's law.